All right, we're going to do 2 examples from chapter 1, and then we're going to move on to chapter 2. And these are just from my notes, but we're going to look at adding vectors using the parallelogram method. Keep running out. Okay, so we got 2 vectors, and you're given F1 is 25 newtons, and F2 is 50 newtons. And you're asked to find the resultant R.
That's 50 newtons, right?
50, yeah. And again, this should be bolded because it's a sum of 2 individual forces, individual vectors. So how would we determine R? Any ideas? Well, hopefully you know we have to draw a parallelogram because we're saying that this is the parallelogram method. So let's do that. And then if we draw the diagonal here, then we get R. What information do we not have here that you need?
The angles.
The components.
You need the angles here. You have the scalar component, but you didn't have the angle. So this is 20 degrees, and this is 130 from the x-axis to F2. So I'm just going to write this down here, and this is 130 degrees. I'll do a different color. Okay, everybody got it? Any ideas on how we can solve this? How can we determine what R is?
We can split it up into x and y components using Pythagoras theorem.
Yep, that's going to be a lot more
Use
complicated.
trig,
You can use trig. What in trig will help us solve this?
sine, cosine.
Sine and cosine.
Wait, say that again?
Sine and cosine.
Sine and cosine, but what law can we use?
Law of sines.
Law of sines would work, but we'd have to do an extra step. So let's try law of cosines. Okay, so first let's figure out, let's redraw this and get our triangle. So we have R, we have 25 on this side and then 50 on that side, right? Because if we have 50 here, then I have 50 on this side. And if I have 25 here, then I have 25 on that side. So we're going to isolate this triangle and redraw it down here. I tried to recreate it as best I could. Okay. Now let's start with figuring out what is this angle here. We're going to call this beta. Let's go back to our parallelogram and solve for beta, which is here. What's our rule for parallelograms? What do all the angles have to equal?
360.
360. Okay, so we're going to have 2 times 130 minus 20, right? That's going to give us this angle here. So one of those, 2 of those, plus 2 times beta has to equal 360. Okay, so the angle on this side plus the angle on that side plus beta here. This is also going to be another beta here, have to equal 360. And from that, we get beta is equal to 70 degrees. Okay, everybody see where I got that from?
Yes.
Okay, so now we know that beta here is 70 degrees. So law of cosines states that this side, r, would have to equal what? The square root of what?
A squared plus b squared minus 2ab cosine of 70.
The angle between them. Yep. So we're going to have 25 squared plus 75, 50, sorry. 25 squared plus 50 squared plus 2 or minus 2 times 25 times 50 times the cosine of the angle between them, which is 70 degrees. And if we take the square root, then we are going to get r, and it's the square root of 2269.9, which is 47.64. And just remember that we're in newtons. So remember to include your units when we're doing all of our problems. Just like when we talked about in mech design, SI units are easier when you're talking about forces because newtons is your force. When we're in US units, we have to differentiate between pounds mass and pounds force. Okay, so we got the resultant R. Now, what if we want to know what is the angle that R makes with the positive x-axis? Because this just gave us the scalar, it didn't give us the direction for the resultant. So we kind of half answered the problem so far. So how to determine what angle R makes with the positive x-axis? This is the second part of our question. Okay, so here was our question 1, how to determine the resultant. And really, we determined it, but we only got the scalar so far. And then we want to know what angle does it make with the positive x-axis. Now we can use the law of sines. Okay, so if we have, we're going to call this angle here alpha. Law of sines then is going to state that the sine of beta over r is going to be equal to what? Sine of this angle alpha over 50. So we know that beta is 70 degrees, so we have the sine of 70 degrees over 47.64 equals the sine of alpha over 50, and you can solve that to get alpha equals 80.4 degrees. Everybody see what I did there? Okay, so we now got this angle here, alpha. Did we answer the question?
No,
Okay, why not?
because that's not from the x-axis.
It's not from the x-axis, so what would you have to do?
Add 20 degrees.
Add 20 degrees, and we get 100.4 degrees. That is the angle that the resultant is making with the positive x-axis.